Good day, ladies and gentlemen. My name is Alvi Hanalino, and I'll be your host for today. Welcome to Probas Circus Carnival, a carnival where a series of games will put your luck to the test. For today's episode, we'll play a total of 5 games, and all of them are based on luck and chance. Enjoy the sights and sounds of our members as they illustrate and play our games. We'll also provide the odds of winning after each game, so please stay tuned and enjoy the show. The first game that we will be playing is the ring toss game. We have here 6 bottles in total labeled 1, 2, 3, 4, 5, and 6. The player is given 3 rings to toss with a 3-meter distance from the bottles. In order to win the game, the player must shoot at least 2 rings randomly. The player here is Mr. Ralph the Triro. Woo! Let's see how well he does in this game. Wow, as we can see, he won immediately by just shooting 2 rings from the 3 given chances. Now, let us apply the random distribution to get the probability of winning the game. So, we rewrite our game here. There are 6 bottles in total labeled 1, 2, 3, 4, 5, and 6. The players are given 3 rings to toss. The rings should land on at least 2 bottles in order to win the game. What is the probability of winning the game? Here, we can write L as the landed rings and M as the missed rings, and find the random variable W representing the landed rings L. Remember that our formula for getting the possible outcomes is 2 raised to k, wherein k represents the given number of samples. So from our given problem, our k will be 3. Since the players have 3 chances to toss the ring, we can now substitute the given and we will have 2 raised to 3, which is equivalent to 8. So now, we determine that there are 8 possible outcomes. We can now get our pattern of it. Yay! As you can see from our table, we got our patterns. We can now determine from here a random variable W, which is the number of landed rings per pattern. From our first pattern, we got 3 landed rings. Our second pattern, LLM, got 2. The next pattern also has 2, and we also have 2 here. The next one, MML, has 1 landed ring. MLM has 1 landed ring. LMM also has 1. And MMM has 0 landed rings. So from that, we can now get our probability. We can get that by getting the frequency over the possible outcomes. The frequency of landing 3 rings is 1, so our probability here will be 1 over 8. The frequency of landing 2 is 3, so our probability will be 3 over 8. Same goes to 1, which has the probability of 3 over 8, and 0, which has the probability of 1 over 8. From this, we can now write our probability distribution table and convert our values to decimal form, since we are getting the probability of winning a game. Since the game of ring toss can be won by landing at least 2 rings at the bottle, we can see from our probability distribution table that 2 is equivalent to 3 over 8 or 0.375. Therefore, the probability of winning the game of ring toss is 37.5%. Let us show you how the probability histogram for this game, so you can visualize how likely we are to win. I hope you enjoyed and learned something from our first game. Our second game will be played by Miss Alisa Ramiro. This game is really famous to all carnivals ever since before. It is called the Hustler game. The mechanics of this game are really easy. The operator has 5 cups facing down on the table. He will then slip 2 balls underneath 2 of the cups. Then, when the game is in play, the operator will shuffle all of the cups. The player needs to guess 2 of which 1 or 2 cups should contain the ball. Let's see if Miss Ramiro can win this game. Wow! Miss Ramiro has nice attention to the cups since she got 1 of the balls. That means she won the game. Now, let's see the chance of winning the Hustler game. We're also gonna use the random distribution just like the last game. Here is how we can get the chance of winning the game. It says that the operator has 5 cups facing down on the table and slips a ball underneath 2 of the cups. The player needs to guess 2 of which. 1 or 2 cups should contain the ball. What is the chance of winning the game? We can use the letter B to represent the cups with the ball, and A represents the cups without the ball. We need to find the value of the random variable x representing the cups with balls. Again, we can use our formula to find the possible outcomes, 2 raised to k. The value of our k here will be 2 because it is the number of times the player gets a chance to pick. So, substituting 2 raised to 2. Our possible the scores on the right side will be 25, 30, and 35. And on the left side will be 15, 10, and 5. The player is given one chance to score the winning points, which is 15 to 25 points. What is the probability of winning the game? To start things up, we should write our given. It says here that our average point is 20. It means that 20 is our mean. It is also said that our standard deviation is 5. Now, in this case, we will have to find the z-score of the two values that are given to us, which is 15 and 25. Let us first get the z-score of 15, so 15 will be our x. Our formula for getting the z-score is z is equal to x minus the mean over the standard deviation. Substituting with our given values, we will now have z is equal to 15 minus 20 over 5. We will then simplify, which will leave us to negative 5 over 5, and that is equal to negative 1. We can now get the value of negative 1 from our normal distribution table or z-score table. -1 is equivalent to 0.3413. Let us now move to our next value, which is 25. We will set our x to 25, and again our formula for getting the z-score is z is equal to x minus the mean over the standard deviation. Substituting with our given values, we will now have z is equal to 25 minus 20 over 5. We will then simplify, which will leave us to 5 over 5 or 1. We can now get the value of 1 from our normal distribution table or our z-score table. And again, 1 is equivalent to 0.3413. Our next step is to add both z-scores to get our final probability. So, 0.3413 plus 0.3413 is equal to 0.6826. We can also denote this as a percentage to represent the probability from 15 to 25, and it would look like the probability of z is greater than 15 but less than 35 is equivalent to 68.26%. Therefore, the chance of winning the game of Drop the Ball is 68.26%. Let us now look at the bell curve graph of our normal distribution to visualize our answer. Here, we can see that our mean is 20 with a standard deviation of 5, and to apply that in our graph, each value must have an interval of 5. After that, we will now locate 15 and 25 in the set of values that we have and mark them. The last step is highlighting the area between the two values to completely visualize the distribution. Let us now move to our fourth game, which will be played by Mr. Dave Soriano. This game is really common at carnivals, and it is called Spin the Wheel. The wheel is composed of 5 sections: red, blue, green, yellow, and pink. Each color has a corresponding point. 10 points for green, 12 points for yellow, 14 points for pink, 8 points for blue, and 6 points for red. The players must get at least 12 points with one chance to spin the wheel in order to win the game. Let us now see how well Mr. Soriano will do and how lucky he will be at this game. Wow! Seems like Mr. Soriano is very lucky today. Let us now get the odds of winning the game Spin the Wheel. We will derive our problem from our game for us to solve easily. It is said that the wheel is composed of 5 sections: red, blue, green, yellow, and pink. Each color has a corresponding point. 10 points for green, 12 points for yellow, 14 points for pink, 8 points for blue, and 6 points for red. The players must get at least 12 points in total in order to win the game. If the standard deviation is 2 and the mean is 10 points, what is the probability of winning the game? The given value that we have is 12, and we have to find the area that is above it, using the same formula from our previous game, which is z is equal to x minus the mean over the standard deviation. Our first step is to substitute the given values to our formula. Our x will be 12, our mean is 10, and our standard deviation is 2. So now we have z is equal to 12 minus 10 over 2. We will then simplify, which will leave us to 2 over 2 or 1. We can now get the value of 1 from our normal distribution table or z-score table. 1 is again equivalent to 0.3413. We can also denote this as a percentage to represent the probability above 12. And it would look like getting the probability of z that is greater than 12 is 34.13%. Therefore, the chance of winning the game of Spin the Wheel is 34.13%. Let us look at the bell curve graph of our normal distribution to visualize our answer. Here, we can see that our mean is 10 with a standard deviation of 2, and to apply that in our graph, each value must have an interval of 2. After that, we will now locate 12 in the set of values that we have and mark it. The last step is highlighting the area to the right side of 12 because we are getting the area above 12 to completely visualize the distribution. We are down to our final game, which is called the beanbag toss. This game will be played by Mr. Chad Pedregal. In this game, there are 6 cans in each section placed in a specific position. The cans are colored red with 5 points, green with 8 points, blue with 2 points, yellow with 10 points, white with 1 point, and violet with 3 points. The players are given 3 tries and must hit down the colors red, yellow, and green with a beanbag in order to win the game. Let's take a look and enjoy how Mr. Pedregal will play this game. Seems like Mr. Pedregal had a hard time playing this game, but luckily he won the game by hitting the 3 winning colors. Now, let us see the odds of winning this game. We are going to apply and use the sampling distribution for this game. Since sampling distribution has lots of processes, let us first see the steps in constructing the sampling distribution of the means. First is to determine the number of possible samples that can be drawn from the population using the formula n combined n, where the big N is the size of the population and the smaller n is the size of the sample. The second is listing all the possible samples and computing the means of each sample. The third one is constructing a frequency distribution of the sample that we obtained from step 2. Fourth is constructing a probability distribution table from the given frequency distribution. And fifth is making a probability histogram for us to visualize our answer. So, getting back to our game, there are 6 cans in each section placed in a specific position. The cans are colored red 5 points, green 8 points, blue 2 points, yellow 10 points, white 1 point, violet 3 points. The players are given 3 tries and must hit down the colors red, yellow, and green with a beanbag in order to win the game. What is the probability of winning the game? We first need to get how many possible samples of size 3 can be drawn by using our formula, n combined n. Our big N is equivalent to 6 because it is the population of our given cans, and our small n is equivalent to 3.67, 4, 4.33, 4.67, 5, 5.33, 5.67, 6, 6.33, 6.67, 7, and 7.67. So from here, we can now write how many times the means appeared obtained from step 2. Now that we are done with this step and completed our frequency distribution, let us now get the probability by getting the frequency over the number of possible samples. So 2 has the probability of 1 over 20. 2.67 is also 1 over 20. 3 is 1 over 20. 3.33 is 1 over 20. 3.67 is 1 over 20. 4 is 1 over 20. 4.33 is 1 over 10 since it appeared 2 times. 4.67 is 1 over 10. 5 is also 1 over 10. 5.33 is 1 over 10. 5.67 is 1 over 20. 6 is 1 over 20. 6.33 is 1 over 20. 6.67 is 1 over 20. 7 is 1 over 20. And 7.67 is 1 over 20. So, from here, we can now get the chance of winning the game of beanbag toss. We can see that our winning point 5, 8, 10 has a mean of 7.67, which is equivalent to 1 over 20 probability. We can convert that to percentage and we will get 0.05. Therefore, the probability of winning the game of beanbag toss is 5%. Let us look at our probability histogram so we can visualize our answer. We have now come to the end of our game show. It surely took us a long time playing with you guys. We would like to thank you for spending your time with us at our Carnival game show. Praba Circus Carnival. We hope you enjoyed and learned something from our show. Thank you for tuning in.